Hello and welcome to Sudoku. Here is a consecutive pair Sudoku puzzle that was created by Indian author Akash Doulani for the latest round of Sudoku Grand Prix. And I'm sad to say that I broke the puzzle during the contest and didn't have the time to start it over, so it will sort of be a live solve, a completely live solve. So where do we start? Oh, first I'll recall the rule. The rule is that this symbol means that those two digits are consecutive. And very important, the lack of a symbol does not mean anything. Those two digits may be non-consecutive, they may be consecutive. So where should we start? Well, obviously those runs of consecutive digits are catching my attention, are drawing my attention. And let's have a look here, because those four digits are consecutive and they don't include a 4. So they must be between 5 and 9. They can't be 1, 2, 3. And one thing in that is that 1, 2, 3 must be in those cells. But more importantly, the digits are either 5 through 8 or 6 through 9. And two options may be ruled out from the beginning. 5 can't be here, so it can't be 5 through 8 here. And oh, that's the only one I can rule out straight away. So 3 options: 6, 7, 8, 9, or 6, 7, 8, 9, and 5, 6, 7, 8. Well, that's a lot of possibilities. Now let's have a look at this one. This one does not include a 7, so one thing is that 8 and 9 can't be on here. So 9 must be in one of those two squares, and 8 must be, well, not here, but 3 positions remain. So what are those digits? Well, they can't contain a 7, and they can't contain a 1 either, because 1 can't be here, and if 1 is among those digits, it must be at this end, and then 2 would be here, which is not possible. So the options are those options. And so, well, that's still a lot, but I know that there's a 4 here. And something interesting with this, there is a 4, these digits are 3, 4, 5, and there is a 4. Same here, we have 6, 7, 8, and there's a 7 here. So this can't include a 4, and this can't include a 7. So now what are the options? So it can't contain a 2, so it's either 3 through 6, 4 through 7, 5 through 8, 6 through 9, but in either of those last cases, there would be a 7 here. So we can rule out those two options. Or rule those options out, not quite sure. And 3 through 6 would put a 4 here. So this one is impossible too. So this one has to be 4, 5, 6, 7, and because of this 4 must be at this end. 5, 6, 7, and now we know there's no 6 here, so this central option is to be excluded. And here we know that this is a 3. And because this is a 3, the only option is this one. And This is a naked single. It sees all digits but 6. And we're left with 189 in this cage, in this box. This row needs a 7. It's not here, it's there. Consecutive with a 6 because 8 is already taken. This puts a 9 here, and now this disambiguates this run of consecutive digits. And this column still needs 1, 3, and 2. So this is 1, 3, and actually we get 1, 3, 8 here, 1, 3, 8. And I notice here a 1, 3, 8 pair, so this one is a 9. And on this row, 3 is here, so 3 is not here. We still need 1, 3, and 2. But note that 1 here would put a 2 here, which would clash with these two. And 3 here has no consecutive neighbor available, so it has to be a 2 together with 1 or 3. And this now can't be a 2 anymore. 2 has to be here. Here we need 4 and 5, and because of this, such are their positions. And now 2, 3, and 9. What's next? This 2 is not here. Can it be here? No, because 2 here would put a 3 there, which would clash. So we get a 2 in this position. This one, this can't be a 1, because it would put a 2 here. It can't be a 3, because it would put a 4 here. So it has to be 4 or 8, but 8 would put a 7 here, which would clash. So it has to be a 4. This can't be a 3 because there's already a 3 on the column. So it must be a 5 with 6 and 7. This digit here is not there. It has to be here. And the remaining digits are 1, 3, and 8. So 1 or 8 here, 1, 3 or 8 there. And we get another 1, 3, 8 triple here. Those digits must be 1 and 3. So lots of 1 and 3 pairs. 2 and 5 here. There's a 5 on the left. And 5 and 8 here. This now must be a 7. Its neighbor is an 8, and we complete this with 1 and 3. What else? We still need 4, 5, and 6. So 5 and 6, 5 or 6 here, 4 or 5. 3 candidates here. This row still needs 1, 3, 4, and 5. 4, 5. This is 1 or 3. So this has to be 4 or 5. But 5 will need 6 as one of the neighbors, and 6 is not available. So this one is a 4, and it disambiguates all of this. Those now must be 3 and 5 in some order. And this puts a 1 down there, and it resolves basically all of the pairs and triples that were hanging. Well, not all of them. This still needs some disambiguation. Here we need 6 and 7. There's a 6 here. This has to be a 2 because of the consecutive dot. 2, 3, this is a 9. Here, 6 and 7, there's a 6 here. Those ones must be 3, 8, and 9. 9 can only go here. 8 here, 3 there. This 3 makes this a 2, this a 3. And then 2 and 2 equals 5, as everyone knows. And this one goes here. And 7 and 8, let's just erase all that's to be disambiguated, and we will be done with this puzzle, which was very well constructed with a very clean solving path, and you would expect no less from Master Akash Doulani. Thanks for watching this video, and see you soon on Sudoku.